Summary of the 5 kinetic theory of gases postulates. 1. Gas particles in constant motion. Gas molecules are in constant random motion, moving in straight lines until they collide with either the container walls or each other. These collisions are perfectly elastic, meaning that no kinetic energy is lost in the process. 2. Negligible particle volume. The volume of the individual gas particles is so small compared to the volume of the container that it can be considered negligible. Essentially, gas particles are points with no volume. 3. No intermolecular forces. There are no attractive or repulsive forces between gas molecules. This implies that the molecules act independently of one another except during collisions. 4. Elastic collisions. When gas particles collide, both with each other and with the walls of the container, the collisions are perfectly elastic. This means that the total kinetic energy of the particles is conserved during collisions. 5. Average kinetic energy and temperature. The average kinetic energy of gas particles is directly proportional to the absolute temperature of the gas. This means that as temperature increases, the average kinetic energy of the gas particles also increases. Summary of the 4 thermodynamics laws. 1. Zeroth law of thermodynamics. If two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. This law establishes the concept of temperature. 2. First law of thermodynamics. Energy cannot be created or destroyed, only transformed from one form to another. This is often referred to as the law of energy conservation. Mathematically, it is expressed as delta U equals QW, where delta U is the change in internal energy of the system, Q is the heat added to the system, and W is the work done by the system. 3. Second law of thermodynamics. In any cyclic process, the entropy will either increase or remain the same. Entropy is a measure of disorder or randomness. This law implies that natural processes tend to move towards a state of maximum entropy, meaning energy transformations are not 100% efficient. 4. Third law of thermodynamics. As the temperature of a system approaches absolute zero, the entropy of the system approaches a minimum value. For a perfect crystal at absolute zero, the entropy is exactly zero. This law implies that it is impossible to reach absolute zero in a finite number of steps.